Okay, for what we have in number 6 is another problem that we can utilize separation of variables. Now for this type of problem, okay, now we could not use the integrating factor for our expression or expressions in y are second order as opposed to first degree. And now for what we have in number 6, now we can maintain the capacity of separating the variables. And if we isolate, okay, the term with the derivative alongside, that is isolate x squared dy over dx, we can move the 2x squared, or make that 2xy squared over, and rewriting we have x squared dy over dx is equal to y squared minus 2xy squared. And once again we can factor. Whereupon we have x squared dy over dx is equal to y squared times the quantity of 1 minus 2x. And as you look at separating the variables, okay, we have dy over y squared is equal to 1 minus 2x all over x squared dx. And in looking at what we have to make the right hand side power rule ready, okay, so we have the integral dy over y squared is equal to the integral of 1 over x squared minus 2 all over x dx. And for the antiderivative of dy over y squared, we have negative 1 over y is equal to negative 1 over x minus 2 times the natural logarithm of x followed by the constant. And we can go ahead and change signs, so we have 1 over y is equal to 1 over x plus 2 times the natural logarithm of x. And now a negative constant is still going to be a constant, so I'm going to keep that what would otherwise be minus c as a plus c. It will have no impact upon the solution. Now we can now combine these terms together into a single ratio. So if we multiply what we have by x over x, these ratios forming where we have a single expression all over x, we have 1 plus 2x times the natural logarithm of x plus c times x all over x. And as you arrive to taking the reciprocal and thus obtaining the solution for y, is going to follow that y is equal to x all over 1 plus 2x times the natural logarithm of x plus cx. And that is going to be our general solution for this problem.